We'll proceed in pseudo multivariate calculus. So, pseudo multivariate calculus. This is a discussion that we are pursuing. Okay, so pseudo multivariate calculus. Writing a simple pseudo code, can I proceed up to the solution that is desired? So this is pseudo multivariate calculus. Multivariate because we are talking about more than one independent component. So we have taken example as calculating the volume of a sphere. Calculating volume of the sphere, the simplest way, non-vector way we have used. Whatever I'm going to talk now, probably it is not available in any of the book. How we can approach with the vector way to calculate the vector way to calculate the volume of a sphere through a simple pseudocode. Pseudocode means it is something that someone has written for the normal cuboid kind of scenario. So in that scenario, how we can proceed? Okay, so idea is, do you have a sphere for which you are trying to calculate the volume? Anyone would ask, do you have a sphere for which you are trying to calculate a volume? I really have a sphere. Okay, this is really a sphere. Okay, this is handle to the sphere, and this is really a sphere. I'm serious about it. This is this is really a sphere. Can you calculate volume of this sphere? Okay. If someone asked me, can you calculate surface area of a surface, then length, I'm sorry, width into height. Okay. What is the surface area? What is the surface area of this? Then width into height. Okay. Width into height. Okay, you're right. Width into height. What about volume of what about what about volume of this? Volume means area. Area means width into height. That is the area. This is called one independent variable, that is width, or someone can say x-axis. X-axis, y-axis. X-axis, y-axis. Now, in that sense, there is one independent component called x-axis and y-axis, that is dependent component. Hop. Understood. You are trying to calculate surface area of a surface. Can you calculate volume of this? Volume of this sphere. Okay, then height into surface area. Okay, height into surface area. Okay, can you calculate the weight of this? Okay, then density into volume. What is common here? I am trying to calculate the result with the multiplication of only two items. People would say width into length into height is the volume. Weight means width into length into height into density is the weight. No, try to get everything in two. Okay, if I'm trying to calculate volume, then it is height. It is height into surface area. That is the volume. Okay, if I'm trying to calculate the surface area, then width into length, that is the surface area. If I'm trying to calculate weight, then density, if I consider density as the height, density into the volume. So that is the concept of starting the kind of pseudo calculus. Pseudo calculus means start with a simple multiplication and division and start changing the multiplication into integral calculus and division into differential calculus. That is the way that we are proceeding. Now we are using vector form. We are using vector form to calculate the net volume. Okay, what is your vector form? Tell me. Okay, so this is my xy plane. Okay, this is my xy plane. This is my xy plane. If this is xy plane, up, this is x-axis and this is y-axis. This is origin from my side. This is xy plane. If this is xy plane, then what is the volume of this? What is the volume of this? Okay, in that sense, it is kept like this. Or I would say, every time I give example, think that this is centered at the origin and this is xy plane, that this is the halfway through. Top is the this is the top hemisphere and bottom is the bottom hemisphere, two hemisphere. Top hemisphere is above the xy plane and bottom hemisphere is below the xy plane. Okay, that is the scenario. Now calculate the volume of this sphere. Okay, if that is the scenario, then calculate the volume of this sphere. Okay, calculate the volume of this sphere. Okay, if that is the case, then I have what is the volume of the sphere? That is height into surface area. Now height I can consider as k unit vector. Height is k unit vector. This is xy plane. This is x-axis, then I unit vector. This is y-axis, then j unit vector. This is I unit vector. This is j unit vector. This is origin. Okay, and this is k unit vector. Simple. X, Y, Z. This is what we think so. Simple. X, Y, Z. This is what we think so. So this is x-axis, this is y-axis, and this is z-axis. Now, in that sense, how to calculate the volume? Volume is height into area. Weight is density into the volume. Area is width into length. Two multiplication of two items. That's it. What is the height? Height, if I take height z, then that is represented as z k unit vector. Z k unit vector. What about the surface area? Height into surface area is the volume. What about surface area? Then x I cross product with y j. Surface area between two vectors. This is xi vector. This is yj vector. Now the surface area is xi cross yj, and then this is the height, that is zk. To calculate the volume, this is called triple scalar product. Triple scalar product is zk dot and in braces xi cross yj. This is the volume. Okay, understood. Now I have a cuboid. I have a cuboid, and this length is, if this width is w, length is l, and height is h. Now you tell me with your great formula, that is zk dot and in braces xi cross yj. If that is the case, xi cross yj, then x is w, wi cross lj, I cross j is k, w l k vector, dot product k and k will give h, h w l. This is the volume of a cuboid, where this along the x-axis width is w, along the y-axis length is l, along the z-axis it is z-axis it is h. Okay, very nice. Thank you very much. So this is called pseudo code. This is what we have to proceed upon. Slowly we will start replacing x, y, z into algebra. Right now, if I take a cuboid, then it is constant. If I take a simple cuboid box, simple 3D box, then it is W into L into height. It is a cuboid. Okay, okay, thank you very much. So can you tell me, please, the volume of this sphere? Okay, consider this sphere is centered at the origin. This sphere is centered at the origin. Then XY plane will cut at the middle. Top is top hemisphere, bottom is bottom hemisphere. Now this is centered at the origin. Anyway, now let's calculate the volume of the top hemisphere. Then it is again zk dot product and in braces xi plus yj, where x is not constant, y is not constant, z is not constant, whatever it is. Now, as per the, let's proceed. What is your volume? Height into surface area. Surface area, we have to settle it down first. Then it becomes xi cross yj becomes xyk. xyk vector. Now we have dot product of 2. zk dot xyk. zk dot xyk. Okay, if that is the case, if someone proceed upon it, zk dot xyk, but we got the area, we got two multiplication more or less, that is z into x and y. X and y, they are together and k vector. X into y together, k vector. And zk, that is separate, zk separate dot xyk, xy and k vector, that is separate. Now there is multiplication of two items. One is z, k vector, and one is xy, k vector. This is where z is dependent upon x and y. If it is a box, cuboid, then height is not dependent upon x and y. How you can say that in cuboid height is not dependent upon x and y? Okay, if we take a cuboid, then if I proceed on x-axis or y-axis, if I proceed on xy plane A, if I take any point on xy plane, height is constant. Height does not depend upon x and y. Height is not variable upon x and y. But if I take a sphere, if I take a sphere, if I cut it into xy plane, if I take different x comma y, height is different at different points. See? At the origin, height is maximum. In on x-axis, when if consider this radius is a, on x-axis the x is a. At that moment, height is 0. Towards negative x-axis, when x is minus a, again height is 0. Towards y-axis, when y is a, then height is again 0. When y is minus a, again height is 0. When it is origin 0, 0, 0, then height is maximum. That is either a or minus a. So depending upon different xy value on xy plane, height is different. Means height is dependent upon xy plane, where we are free to take x and y any point there. But x and y, if you see, if I cut it like this, then this will, if I cut like this at the center, if I cut it like this at the middle, if I cut like this, then this will go inside it. And if I see the region here, it will be a circular region. If I pierce this like this, then it will go inside it, and at the center here, okay, I have not marked it. Consider center here is the origin, and center of this is the origin. This is how it is placed. Then if someone try to draw on the xy plane, it will form a circle, circle of radius a. That is the radius of the sphere also. Height at the center is a. Bottom to the minus xy plane, it is minus a. Okay, the circle that is drawn on the xy plane has radius a. X is minus a to a, x is minus a to a, and y is minus square root of a square minus x square to square root of a square minus x square. Because if it is a circle, then there can be only one independent component. If it is a rectangle on the xy plane, then both are independent to each other. If x is growing, then y remains constant. If y is growing, there is a rectangle. This is xy plane. and there is a rectangle on the xy plane. If I grow in x, then y is constant. If I grow in y, then x is constant. They are not varying with each other. But if it is a circle, then in the limit raised area, they are dependent upon each other, whatever it is. Now we are coming back to the same situation. What is the volume? Height into surface area is the volume. Height is zk dot surface area is xyk. Now, if there is multiplication of two items and one item is dependent upon other, z is dependent upon xy plane, then it will turn into integral calculus. Zk dot product of d of, now against the independent component we will place d there. Zk dot d, small d, and in bracket xyk, xyk or xi cross yj or xyk. Now z is dependent upon xy plane. This is the way we have to proceed. Now see, simple multiplication we reframed into integral calculus. Zk dot product d of in bracket xyk. Now, since it is d of xyk, xy is the plane we have taken. If I am taking a sphere where xy plane is a kind of is a circle, polar coordinate is a circle, then altogether xy I can take one point to another point. There is no harm in it. So I can take one point on xy plane is minus a comma 0. Or I can take different point along the surface. Like I have to integrate it. I have to take the coverage. After all, what is your surface area? Someone will ask. Okay, you said zk. So I understand z is the height. Dot d of x into y. X into yk. X into y talks about surface area. Surface area into height. Just see numerical to algebra how nicely we are converting, and then algebra to calculus, and then it is vector. Everything we are adding now. Zk, z I understand it is a height. Dot d of area. Height into area is the volume, right? So z is the height. Dot d of xy. Xy is the area. D of xy plane. D of xy. Xy is the area. What is the area? Area is when this sphere is centered at the origin, this plane will go inside it and the center of this will coincide to the center here. This is centered at the origin. Center of this plane is the origin. Here it is the origin. This will go and coincide at the origin. In that sense, on xy plane, it will make a circular area. That is the area. Z is the height into on the xy plane circular area. Circular area into height is the volume of the top hemisphere. Circular area on the xy plane. If this get pierced into it, it will make a circular area on this plane. Okay, where circular area, on the circular area, half of the sphere is below it and half of the sphere is above it. Okay, the above it, that is height z, into the surface area, that is circle, is the volume, top hemisphere. Surface area into height, that is below the xy plane, is the volume of the bottom hemisphere. You add it, you get the net value. Oh, I didn't know. Okay, what is the surface area? That is pi r square. Now area of this is pi a square. A is the radius, then surface area is pi a square z. That is the one. Okay, z at the middle is a, then pi a cube. Okay, this is pseudo code. Pseudo code is height, that is zk dot d of surface area, d of xyk. Now this surface, since we have come to integral calculus, this surface area will come through the snake sign, that is limit. That is along the parameter. We have to take the limit. That is minus a0 to 0a to a0 to 0 minus a. That is the limit of the surface area. All around we took. Or I can divide into x and y separately. x is minus a to a, and y is minus square root of a square minus x square to square root of a square minus x square, because the circle that is formed on the xy plane is a radius a. X square plus y square equal to a square. That is the equation of the circle out there. What is z? We talked about z, right? X square plus y square plus z square equal to a square. This is the equation of a sphere. Z equal to square root of a square minus x square minus y square. Okay, let's go back, and now the integration sign limit. Limit is for the surface area we are taking, and then height is z. Surface area is a circular region on xy plane. So x and y limit separately. X is minus a to a, and y is minus square root of a square minus x square to square root of a square minus x square. If I take one integration sign, then it will go minus a comma 0 on x-axis to a comma 0 on x-axis. But it will not take care that nicely the way the other way it is taken. Anyway, zk dot d of xyk. If I produce this dot product, then it becomes z d of xy. Z d of xy. If someone makes kind of a bigger thing out of it, d of xy, d of xy, how I can break into dx dy. D of xy plane where x-axis and y-axis are orthogonal to each other. D of xy I can write as dx dy, no problem, if they are orthogonal to each other. Okay, in that sense, we can write dx dy. Now, this is z dx dy integration x is minus a to a, y is minus square root of a square minus x square to square root of a square minus x square. So that is the net volume of the top hemisphere. Someone can calculate it. I'll try to calculate it, and then we will get the result. Z is the square root of a square minus x square minus y square dx dy. Consider y equal to square root of a square minus x square cos theta. Many times I have given this example, this reasoning. Y equal to square root of a square minus x square, and then separately cos theta. Then dy equal to square root of a square minus x square. Considering this is independent of y, cos theta will turn into minus sin theta d theta. Now whole z is the square root of a square minus x square minus y square. It will become a square root of a square minus x square root of 1 minus cos square theta, that is sin theta, into dy will become a square root of a square minus x square minus sin theta d theta. Now whole becomes limit x is minus a to a, y is minus square root of a square minus y square to square root of a square minus y square. Square root of a square minus x square cos theta into square root of a square minus x square, I'm sorry, square root of a square minus x square sin theta into square root of a square minus x square minus sin theta d theta dx. Anyone I can take prime, dx or dy. Now in that sense, minus I can keep outside, and it is, and a square minus x square I can keep outside. It is now sin square theta d theta. Sin square theta d theta. Okay, in that case, sin square theta d theta integration is theta by 2 minus sin 2 theta by 4. Now integration theta 1 to theta 2. That is the concern, theta 1 to theta 2. Now, okay, we have y equal to square root of a square minus x square cos theta. Theta equal to cos inverse y by square root of a square minus x square. When y is minus square root of a square minus x square, then it becomes cos inverse minus 1 pi. When y is square root of a square minus x square, then cos inverse 1, then 0. So theta is pi to 0. Now we have integration result is theta by 2 minus sin 2 theta by 4, pi to 0. 0 means all, minus pi by 2 sin pi 0, minus minus pi by 2. Minus I had kept all right outside, then it becomes pi by 2. Now pi by 2 will go outside, and then a square minus x square will come inside, dx minus a to a square minus x square dx minus a to a. What is a square minus x square dx? That is a square x minus x to the power 3 by 3 minus a to a. If I substitute a, then a to the power 3 minus a to the power 3 by 3. That will resolve into 2 a to the power 3 by 3 minus, and then minus a I have to substitute. So minus a will add, it will make it 2 multiply by 2, because same thing will repeat again. So earlier it was 2a to the power 3 by 3, it becomes 4a to the power 3 by 3. Outside pi by 2 is there. Then it becomes 2 pi a to the power 3 by 3. That is the volume of the top hemisphere that we calculated. Multiply by 2, then it becomes 4 pi a to the power 3 by 3 is the volume of a sphere through vector and pseudo code. That is, height into area is the volume. Simple. Okay, this is the most generic way in approaching any solution. Height into surface area is the volume. Length into width is the surface area. Density into volume is the weight. Okay, this is 4 dimensional. Now anyone is free to go beyond it. Okay, very nice. Thank you very much. Whatever you told is understood to me. If height into width, height into area is the volume, then area into height is also the volume. Okay, very nicely you took that if this is the surface area into height is the volume. This is what you talked, right? Okay, if this is the surface, if this is the surface, if this is the surface, then this surface, then this height into this surface also comes into the same picture, right? If height into base surface area is the volume, then height into top surface area is also the volume. Okay, I can prove it. I can take a simple cuboid. I can take a simple cuboid, and in that cuboid, okay, this is the simple cuboid I am taking. Up, not visible. This is the simple cuboid. Now I am boasting that, okay, you want to calculate volume, right? Okay, height into base area. This is the base area. Base area into height is the volume of a cuboid. Whenever we try to calculate volume, take the simplest case. If we are calculating in Cartesian coordinate system or rectangular coordinate system, then this is the simplest case, the de facto for the Cartesian coordinate system. Okay, if height into base is the volume, then height into top base is also the volume. Can you prove that? Okay, can you go in through that? These are the proof not available in any of the book. Repeatedly I am saying. Okay, if height into base area is the volume, then height into top area is also the volume. Can you calculate it? Same fashion. Okay. Now, if you see this, the top hemisphere we are talking, then height into this area, top area. Now, the base area was xi cross yj. Whatever, top you cannot take xi plus yj, xi cross yj. How we can proceed into it? How to calculate volume of a sphere with a concept that height into top area is again a volume. If height I say zk, height is always zk, dot product with the top area vector. What is top area vector? Then it gives the volume. Height is zk dot product and then top area vector. What we did right now is height, that is zk dot product with the xy plane area vector, that is xi cross yj. What about top area vector? Okay, that is height, height dot product with the top area vector. That is the volume. Can someone calculate it? This is assignment. Volume of any 3D shape as height into top surface area. Surface area vector. Height vector dot product with the top surface area vector gives the net volume. This is what we have been trying. Height with the xy plane surface area vector gave us volume 4 pi a to the power 3 by 3. Height vector into top surface area vector should also give the volume. What is top surface area vector here? If it was placed in xy plane, then xi plus yj dot zk xi cross yj dot zk we took. But if this is the surface area, it is higher than zk dot product with what two cross product I'll take. This is like this. Okay, that is assignment. That can someone find the surface area of the top through pseudo code, not for the sphere, for anything. Okay, if someone calculates pseudo code for the surface area of the top surface dot product with the zk, then we can find then limit what we'll take for the because top surface area if we go for integral calculus, then net surface area will transform into limit. Otherwise, if it is not integral calculus, direct numeric value we can multiply. If it is not calculus, integral calculus. If it is integral calculus, then surface area vector will be transformed into d of surface area vector. In that sense, the net surface area will be transformed into limit. This is what we did. Okay, so we will proceed on upon it. Please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code.